city. And along with my colleague Michael, we'll share with you the experiment and experience we have with Libfabric, which is a framework to be used to do media sharing. So we know that the broadcast industry is moving toward a software-based approach, right? It's the kind of data we're trying to exchange is not different from HPC. We try to leverage different technologies such as RDMA or whatnot. The only difference we have is, no, our data is real time, right? And the data exchange is sustained. So typical setup, you have a compute node, you have a process there, you want to share data between this process and some other process, right? And you want to do this as seamlessly as possible if you have a remote node that has a compute process, right? So you share data. That's basically the approach. So we play with that framework that's called Libfabric. It pretty much abstract the network and allow us to focus on the data and not care too much about the network or how we exchange data. It's an API. It's low level enough. It abstracts diverse network technologies, as I said before. It supports multiple OS, and it can be used in the cloud, on-prem, on whatever hardware you decide. Right? Just a brief history of what is Libfabric. It's an open source project. It has been initiated somewhere around 2015. It has over 192 contributors. It is active. There has been an update recently, I think somewhere in December or January. And it has been used within Lefebvre HPC since 2018. So with that, I will hand off to Miguel.
All right, thank you, Citi. So that's going to be the content of the rest of the presentation. So first, we're going to have a look at have a technical introduction to Libfabric to see what Libfabric has to offer us. Then we're going to look at some use cases with video and audio and deploying that into different type of environment, on-prem and on the cloud. And finally, we're going to have a look at the cost of using Libfabric. That's the wrong. All right. And before we talk about Libfabric, just a quick survey. Who knows about Libfabric here? Okay. So Libfabric uses the what I call the asynchronous programming model. So if you're interested in having high throughput, low bandwidth, that's the programming model that you're going to need. So basically, you have two queues. You have a queues where you submit work to, and then the network device will pick up that work, will execute it, and then will give you completion feedbacks to a completion queue. So because you're not blocking during the transfer, what you can do is you can interleave processing and sending more data. All right, so what exactly is Libfabric? So Libfabric is divided in two different components. So the first one is the Libfabric Core API, which is basically a programming interface. And it's divided in 4 components. So you have what's called the Discovery API, which lets you discover Libfabric devices. The Communication API, where it allows you to connect two endpoints together. The Completion API, which lets you interact with the completion queue. And then finally, the data transfer, so different type of data transfer semantics. And then the other part is the provider library. So basically what it is, it's multiple concrete implementation of the Libfabric Core API. So if you're gonna read about Libfabric, one word that you're going to see a lot is provider. So what exactly is a provider? So it's basically a bridge between a sharing technology, networking, or IPC technology that is exposed through the Libfabric core API. So for our exploration, we were interested in using Libfabric for internode communication, but one thing to note is that it also supports intranode communication through the shared memory provider. So it offers typical TCP, UDP communication, but also it provides through the verbs provider RDMA devices, and also EFA for cloud if you're using AWS. So that's just a few list of the providers that's available. There's more than that. And also, since it's open source, it's extensible. You can add your own provider if you have a device that handles network transfers. All right, so as we've seen, there's many providers. And one question you might ask is how difficult it is to select a provider. Well, here's 3 lines of codes that show you how to select 3 providers. So it's basically 1 line of code to select a provider. So it's pretty simple. All right, so now we're gonna have a look at all the different parts of the core API. So the first one is the discovery API. Basically, the role of that is to let you discover your Libfabric devices that are available, but also the capabilities that they have. And there's 2 ways to actually inspect the providers that you have. So you have the binary that's called PyInfo, which is basically a command line app that lets you inspect your system. So in the bottom, you can see I've run the command on my PC, and it lists some providers there. And then the other way is by code, so basically by using the py-get-info function. All right, another API is the data transfer API. So if you're familiar with RDMA, data transfer semantics, it's pretty much the same thing. So you have 2-way operations and 1-way operations. 2-way operations is basically the same thing that you would use with socket programming, so send and receive. So both the target and initiators are involved. Libfabric also adds a superset over send and receive with what they call the tag matching. And basically what it is it's the same send and receive, but you can identify your send and receive to make sure that on the target, your send will go to the right buffers. So the other one is the 1-way operations. So basically, the 1-way operations are called remote memory access. So you have some memory that lives on a target, and the idea is that you will have other node that can actually modify the memory on the target. So modify or read it. And this actually requires memory registration, which I will be talking about later. And finally, Libfabric also offers more higher level operations, which are called collective operation, which involves many nodes. These are more complex operations. We have not personally used them, but because they don't fulfill any needs that we have, but do note that they also have that. Okay, so the communication API, so now we know how to discover the different providers. We know what kind of data transfer we can do with them, but now one question you might ask is it easy to connect these endpoints? So there's 2 ways to connect the endpoints. There's the what they call the connected communication way, which is basically typical socket programming, server and client architecture. One problem I have with that API is that the support is incomplete. Some providers does not support that that mode, and also when you're using that mode, depending on the provider, maybe some operations, data transfers are not actually supported. My preferred way is the connectionless communication, where it's basically what they call is the address vector, where it's a record of destinations that you will be able to do operations on. And basically, when you add address to that record, it will establish transfer paths. So if you have any ARP, stuff like that, it's going to be done when you add them to the record. And finally, the last API is the completion API. So as you remember with the programming model that I showed, there's the completion queue where you will get feedback for the transfer completions. So there's two ways of doing it. So either with the blocking call. One thing I don't like with the blocking call is that the latency will be affected depending on the scheduler, the OS scheduler that you have. But also, and I think that's the deal breaker, is that not all providers will support the blocking API. The other one, which is the one that I prefer, is the non-blocking API. So basically what it is you just pull the completion queue to see if there's any items, and it lets you choose the polling rate, and you will get the lowest possible latency because the OS scheduler is not involved into that. All right, so the last part about Libfabric is the memory registration. So if you're doing RDMA transfer, basically you have some buffer that lives in user space, and if you do RDMA transfer, basically you're going to give ownership of that buffer to the NIC card so that the NIC card can bypass the OS. So that's why you need to tell the OS that it cannot modify the memory or mess up with the memory or move the memory around. Also, during memory registration, you're going to have to give access permissions. So as you might recall with one-way operations, so you have one buffer that can be modified by basically anyone. So with access permissions, that's where you're going to say, OK, my buffer can be read from or written to. And basically, when you do registration, you're going to get what's called an R key, so a remote protection key. And then you can use that key to share that to other peers that you trust that can write or read from your memory. All right, so here I just wanted to show how easy it is to actually use Libfabric. So there's two phases, the setup phase, so step 1, 2, 5, which is basically you select a provider, you create your endpoint, create your completion queue, you create your address vector, you add the peers that you want to talk to, then you register your buffers, and then setup is done. You're up to the data transfer. And same thing with the data transfer, it's those two lines, so the tsend and the receive. And the line will not change depending on any providers and any context that you're going to use. So you just write these two lines once, and you never change them. And you can deploy everywhere. All right, so now that we know, we have a brief idea of how Libfabric works and what it has to offer, I wanted to show some use case using video and audio and deploying them in different environments. So the setup that we use, pretty simple. We have on-prem, we have 2 nodes. Both have a Connect X5 attached to them, which allows me to do RDMA transfers. And we have a Arista switch, basically. On the cloud, same kind of setup. So we have 2 instances with an EFA device attached to those instances, and we have a simple VPC. So pretty simple setup. So the first test that we did was we wanted to send a video uncompressed stream, so a full HD 60 Hertz. And we had some key targets with the media throughput, so about 3 gigabits, and then latency up to 1 frame. So we ran some experiment. So we ran with TCP, with verbs, and then with EFA. And we had those throughputs, which are pretty similar, which was what we were expecting. On the latency side, well above 1 frame, so that was good. And I think the interesting thing is the CPU usage. And as we can see with the verbs and the EFA, it's much lower than TCP. And it makes sense because you're basically offloading all the networking to the NIC card, which is very nice because then you can use that CPU usage to do actual processing instead. And the nice thing with Libfabric during that test is that we've written the binary once, and then we were able to deploy it wherever we wanted, and we didn't change anything. Yeah. On the audio side, there's 2 main ways of representing audio into memory. So either interleaf, where it's more suitable for IOs, but less suitable for DSP because you have to do packing and unpacking. And then there's split or planar audio, which are more suited for DSP, but less convenient for IOs. But what if you could actually use planar or split audio only? And actually, if you're using RDMA, you can leverage something that's called DMA scatter-gather. So you have multiple non-contiguous buffers, and you might want to send them into a single transfer. And actually, Libfabric supports that. So you can leverage RDMA scatter-gather. And if you're using a provider that does not support it, like TCP, for example, Libfabric will handle the packing and unpacking of the buffers for you, so things that you would have to do yourself anyway. So that's pretty nice. All right, so finally, we're going to have a look at what is the cost of using Libfabric, because we're getting all that nice abstraction, but is there a cost to it? So we ran some experiment and comparing Libfabric using RDMA versus just using RDMA directly. And as we can see, we get a latency cost of about 10 microseconds maybe. So for a video, that's basically nothing. What about audio? For audio, 4 microseconds, that's not even 1 sample, so that's pretty good. Then we run the same test, but with TCP. What about TCP? Again, same order of magnitude, pretty good. What about audio? Same thing. So, in conclusion, Libfabric really indeed lets you focus on your application. You don't have to worry about what's the networking device. Also, it provides you with all the data transfer semantic that you would expect if you're doing networking. And then finally, as we saw, there's no really trade-off of using it.